you so much. It's been great connecting with you.
Yeah. Hello, everyone. Good evening, good afternoon, good morning, depending on whichever part of the world you are joining us from. Thanks for joining the last meetup of 2022 by the Community Kaggle Days Meetup Delhi NCR. So, this is our 42nd meetup, and we are so glad to host Usha for the second time on our community's event. Like we have hosted her previously in one of the meetups earlier on a very interesting topic. And today we are hosting Usha with a very interesting topic around accelerating machine learning using JAX. And I hope this session becomes useful and become one of the most important session that you have attended in 2022. So without further ado, I hand it over to Usha and then we can start.
Yeah, sure. Let me just start sharing my screen. Share screen.
Yes, it's visible.
Yeah. Before I start, I would like to thank Ion for hosting me, and for all, I would like to appreciate him for all the great work he is doing with Kaggle Days community and outside that as well. He's one of the important reasons why there are a lot of Kagglers coming from India. Thank you so much, Ion, and keep doing great work in 2023 and beyond. And with this, let's get started with the topic accelerating machine learning research using JAX. Of late, I started giving a lot of JAX talks, primarily because, through talks, I thought I can enhance my learning of JAX as well. And it's a very, very interesting framework which is coming from Google's DeepMind. And recently, I won the Kaggle ML Research Spotlight Award for writing one of the notebooks in Flax, and I wrote the same notebook research paper I've implemented both in TensorFlow and in Flax JAX as well. So you can go to my profile Tensor Girl and you can check out the notebook. It's a gated tab transformer paper. And with this, let's get started for the talk. So, what are we covering today? We are going to cover what is JAX, and we're also going to cover the features of JAX. We'll be covering up the most important component of JAX, which is going to be the device array. And we'll see the comparison between speed, between device array and NumPy array. And some of the important features like JAX differs a lot from its counterpart NumPy in terms of few of the important features like immutability and all. So we'll discuss what is different in JAX, particularly about immutability. And there are 4 or 5 important concepts on why JAX is so powerful. And we'll see those concepts, what is the reason behind JAX being super, super fast. And one is automatic differentiation, JIT compilation, vectorization, parallel evaluation, and all of that. These are some of the features why JAX is so powerful, and you can achieve like 15 to 20% faster speed compared to TensorFlow and PyTorch. So be looking a little deeper into these concepts, and we'll finally cover up with pseudo-random number generation using PRNG. So this is one important feature which is JAX is mostly similar to NumPy in a lot of ways, but when it comes for pseudo random number generation, it is like totally different. And we'll explore this concept finally. So this is going to be the agenda for today. And what is JAX? So JAX is a machine learning library which comes from Google's DeepMind. So it's predominantly started with the research world. So coming from Google's DeepMind, rightly discovering all of the internal, research work which is being done by Google as well. And there's a lot of campaign for JAX from Google, particularly this year. And it's nothing out of the world. It has a similar NumPy like API. So most of the JAX features which you use is similar to NumPy, and so it's you wouldn't feel like you're learning something totally new. No, you will never get that feeling. It is mostly similar to NumPy in most of the cases. Again, as I mentioned earlier, there are a few places where it's differs totally. One is random number generation, which we will be touching upon in the concept in this class, but otherwise it's going to be similar to NumPy. The API is similar. Most of the functions in NumPy and SkyPy, if you see a lot of functions, linear algebra functions and all that, it has a corresponding wrapper in JAX. So instead of using JAX NumPy as NP, you are going to use jax.numpy as JNP. So most of the NumPy and SkyPy classes has a corresponding wrapper in JAX. It's very simple, it's very flexible and easy to adopt. And features of JAX. If you see the features, you have certain features like automatic differentiation, you have features like automatic vectorization, and you have pseudo random number generation, and you can do a lot of transformations very very easily. So these are not concepts which is exclusive to JAX. If you take differentiation and all of that, it's already available in TensorFlow, and PyTorch also we have automatic differentiation, but JAX does it differently. So the way JAX does this is very powerful, and the mechanisms which it uses underneath behind the hood to do it is very very powerful, which makes it super fast. We'll be taking a little deeper. This is not an A to Z session for sure, because this is a 40-minute session. So we'll cover the most important topics. And JAX, if you see, you can call it as NumPy or as accelerators. JAX plus TPU combination is going to be super powerful, and it is very, very fast. So, the other name for JAX, people sometimes call it as NumPy on accelerators. And just-in-time compilation is a technique which always existed, but JAX powered with just-in-time compilation is super fast. And these are some of the very, very important features of JAX, which makes it so powerful. So now let's get deeper into all these features and explore JAX a bit more. So as I already told you, it has a NumPy-like interface. So if you take import NumPy as NP, here I'm going to replace it with as import jax.numpy as JNP. Now, wherever I had used NP earlier, I can use JNP. So, creating an array object. See, the device array is a core primitive object of the JAX system, and creating a device array is similar to creating numpy.np array. It's very similar. The import statements and the array creation functions, everything is similar. So, it has a similar wrapper to numpy. And so, I'm just printing out X. It's a device array of 10 numbers. So NumPy array versus device array. If you see, want to see, I'm creating a NumPy array, and then if I have to convert this NumPy array to device array, I can just do it as jnp.array, and I can get a device array out of a NumPy array. But if I'm going to do an operation, like if I'm going to do a dot product, so of a numpy array, and if I'm going to do a dot product of a device array, and that's it's going to look like this. So I've done the first operation, dot product of a numpy array and a dot product of a device array. And if you see the execution time, you may not see that kind of a huge difference. So for simple one line statement, there's not much of a performance you can see. The secondly, the entire code is written in CPU. So in CPU, JAX does not give that kind of a great super performance. But when you test out the same code in TPU, you will start improving, seeing the performance improvement, because JAX is mainly built for parallelization. So JAX works really well with multiple GPUs or multiple TPUs, or even a TPU as single TPU as an accelerator as well. So in CPU, you may not see that much of a performance gain. Secondly, when you see the first execution, first time when you call a function, what happens underneath is that there's a lot of process which happens. First, the code gets converted into an intermediate expression called JAXPer. And then JAX uses XLA as a compiler, and then this XLA converts this JAXer back into an assembly code. So the first time any function gets called, there's a lot of intermediary process which happens. So it definitely takes some time, for this to happen. And unless and until so that is why you may not see that much of a performance gain in the first time a function gets called. But the consecutive time it takes to call the second or third time you call a function, there'll definitely be a performance improvement between JAX and the NumPy array. And one more thing here, if you notice, I would have written jnp dot block until ready. So the reason why this block until ready is written, because JAX is asynchronous by nature. So anytime you want to measure the compute performance or execution time, what you should do is you should not mention, unless and until you mention block until ready, you will never be able to compute the execution time. So this is very very important to measure the compute time or execution time. So block until you mention block until ready, since JAX is asynchronous by nature, you cannot compute the execution time. So these are some concepts which you need to be aware of. Next important concept about JAX is immutability. So NumPy arrays, all of you will be very familiar. You can do an in-place updation, but JAX does not do an in-place updation. So if you're going to do, I have created a 3 by 3 array, and in the 3 by 3 device array, I'm trying to do an updation of the first row, trying to update the first row, all the elements of the first row as once. And this throws an error in JAX because JAX is immutable. JAX device array is immutable. So if you try to do an in-place updation, it will throw you an error. But in machine learning, as you already know, you cannot be without updating your arrays. Array updation is a very, very important concept. So how do you do an array updation in concept if you cannot do an in-place updation? JAX allows you to update the arrays by using attribute, and at the first row set the values as 1. And it, you cannot do an in-place updation, but you can create a new array and you can store it. This is the JAX allow. So I first statement, I've created 3 by 3 arrays of zeros, and in the second statement what I'm doing is I'm taking the first row and updating all the zeros by 1 and storing it in a new array called updated underscore array. So I'm not doing an in-place updation here. I'm doing storing it in a new array. So JAX only does not allow in-place updation. If you have to do an array updation, you will have to store it in a new variable. So these are some important, philosophy around which JAX is built. And the second thing is pure functions. So if you take any pure functions like cos x or any of these functions, it always, whatever value you give as an input, the same for every value. It does not have side effects. Pure functions are functions which does not have any side effects. For any given value of input, you will always get the same output. That is the whole concept of pure functions. So if I take cos x, if I give, whenever I give cos of 0, it is always the same value. Cos of 90 is always the same value. So these are functions which does not have side effects. When I say side effects, there's no global variable or global state which is maintained that you update it inside the function and things like that. So since there's no global variables and things like that, then pure functions is always doesn't have a side effects. And the reason why there's a whole concept of pure functions being used in programming world is they are reproducible and you can do a lot of parallelization with it. Since parallelization is one of the most important philosophies around which JAX revolves, pure functions and JAX is a very very good combination. So JAX encourages pure functions as much as you can. So most of the transformations of JAX works only with pure functions. JAX does not explicitly put you a constraint that you shouldn't have function impurities, but the one thing that JAX tells you upfront is if you have impure functions, there is no deterministic way that the function will always perform. It is very indeterministic. If you have impurities in function, sometimes a function might do in a certain way, sometimes it might. So JAX doesn't guarantee you a certain behavior whenever you use impure functions. You can use impure functions at your own risk. JAX encourages you to use pure functions as much as possible. So to summarize, JAX transformation works really well with pure functions. And there's in place updation not allowed in JAX, and immutability of inputs and global states is not allowed. So, this is a summary of JAX and pure functions. Next, let's move into very important concepts like automatic differentiation. So, automatic differentiation is a very, very important concept. See, you have automatic differentiation in TensorFlow as well. TensorFlow supports automatic differentiation. PyTorch also does automatic differentiation, and this is separate library called AutoGrad, which also does automatic differentiation. So the why we do automatic differentiation in machine learning particularly is because we wanted to calculate the derivative of a function. To calculate the derivative of a function, you can do it in multiple ways. You can also do it using numerical differentiation. You can also do it using symbolic differentiation, and you can also use automatic differentiation. But both numerical differentiation and symbolic differentiation has got a lot of problems, and that is why we go for automatic differentiation. So there's automatic differentiation. Most of the machine learning frameworks today, instead of, they don't support numeric or symbolic differentiation. They use automatic differentiation. Both have got numerical and symbolic differentiation has got problems with truncation and swelling of the inputs, and they have a lot of disadvantages to it. And that is why automatic differentiation is predominantly used in the machine learning world. And how does JAX do the automatic differentiation? It has a transformation called grad, using which JAX does the automatic differentiation. So I am going to use throughout for the next 3 to 4 transformation. I'm going to use softmax and a softmax activation function as an example. So here, if you see, I'm using a softmax activation function. So if I have to do an automatic differentiation with this particular function, all I have to do is grad of softmax, and that's it. If the function has a parameter, then I can pass that parameter, and then I'll be able to get the derivative of the function. This is very easy. I don't have to bother or mess with so many things. Whenever I want to do an automatic differentiation, I can call this grad transformation, pass the function name, and the if the function has a parameters, I can pass it as a parameter values as well. So the job is done. And if you there is a lot more which you can do with automatic differentiation in JAX. See, you can calculate the higher order derivatives very, very easily. So calculation of higher order, fourth order derivative or third order derivative is very, very easy. So whenever I want to calculate the third or fourth order derivative, I can do it as grad of grad of grad of grad, and I'll be able to calculate any number of order of derivatives very, very easily with JAX. The second thing is the whole concept of computation of Jacobians and Hessian's matrix. The reason why whenever we do want to calculate Jacobian, so Jacobian matrix is nothing but it's a partial derivative whenever the function has multiple inputs. Most of the times we don't deal with functions with single input, we deals with function with multiple inputs. So you may have to calculate the partial derivatives of all the with respect to both the inputs of a function, so which is nothing but a Jacobian matrix. And this Jacobian matrix calculation is very, very easy using JAX. There are particular transformation functions like for doing the Jacobian computation of Jacobian matrix as well. And again, if you take Hessian matrix, which is nothing but a second order partial derivatives, which is again the computation of SCN matrix is also very easy. There are transformations which are available. You can call those transformation functions and you can pass the function name, and you'll be able to get compute these Jacobians and SCN matrix very easily as well. There are a lot more transformation functions with regards to automatic differentiation available, and you have an autodiff cookbook in JAX documentations, which is very, very useful for exploring these functions, and I would highly recommend going and checking that out. And I would like to show some statistics. If you see, you have an autograd. This is statistics of the execution time with when the batch size is 1024. There's a comparison of the autograd libraries. Autograd itself is a separate library, and you also have TensorFlow also does automatic differentiation, and PyTorch also does it, and JAX also does it. So if you see, PyTorch and JAX way of doing automatic differentiation is very powerful, and it is giving you best performance. And you can see much more performance improvement as the batch size is higher. So for compared to 1024, when the batch size is the 4096, the performance is better. So as and when for larger batch sizes, JAX is showing you good improvement. But I will also like to point out that PyTorch performance is also equally good. And the next concept here is just-in-time compilation. So the whole concept of just-in-time compilation is doing compilation dynamically at the runtime. So basically, you convert your do it has two processes. One is a source code translation, and then converting the bytecode into the machine code. So this is not a new concept. Just-in-time compilation have been around for a long time. I mean, if you were a Java programmer also, you would be aware the Java compiler uses just-in-time compilation as well. So there are a lot of advantages for this just-in-time compilation. That is why many programming frameworks started using just-in-time compilation. Some of the important highlights which I would like to highlight is it uses less memory, which is the most desired thing. Memory is always a constraint when you go for huge programming things. So memory usage is very much a concern. And machine learning engineers also, deep learning engineers, they always, when they start dealing with video data or they deal with millions of images or files, they always wanted 64 GB memory, sometimes 96 GB memory, because memory is one of the important factors in a machine learning pipeline. So you would always desire a compiler which uses less memory. So compilation technique, so just in time compilation is preferred, and there are a lot of code optimizations which you can do on the flow. And you take TensorFlow ecosystem, you have something called accelerated linear algebra. And this accelerated linear algebra is the compiler which TensorFlow ecosystem and the JAX ecosystem uses to achieve this just-in-time compilation. So, if you want to know more about accelerated linear algebra, which comes from the Google ecosystem, you can go to the TensorFlow documentation. There are huge, articles, huge number of articles which is written on XLA and how it basically works and different API it exposes and all that. So, I would highly recommend reading it. But if I have to just summarize in a line, then I would say what basically happens in XLA compilation is, what XLA compiler basically does is it takes the high level operations written in your code and converts it into a low level target specific operations. And same XLA is used in TensorFlow as well. So it takes if it does compile in the TensorFlow context, it will take the high level TensorFlow operations and then convert it into a low level operations. The same XLA is used by JAX as well, and JAX, well, it will take the high level operations and convert it into a low level operations. And XLA compared to the other just-in-time compilers, XLA is a lot more advantages as well. So if you take the other just-in-time compilers, there are many other just-in-time compilers available in the even Java compiler is a just-in-time compiler as well. So the reason what is very very advanced, what is some of the important highlights of XLA is you can achieve a faster execution speed, it uses less memory, and it has a better portability. Now, enough of theory, let's go and see some statistics. If you take the throughput sequence, you can achieve the best performance with XLA combining with the grad. Transformation and XLA can give you best performance. So with XLA, you can always achieve the best performance, which is very significant from this statistics. And now that we have covered all the theory, let's get dive deeper into the code and actually see some kind of a statistics which is easier for you to understand. So I've taken the same softmax function. I'm doing a just-in-time compilation of the softmax function, and then I'm also doing a just-in-time compilation of the same softmax. I'm computing the execution time with JIT and without JIT. So the first time without JIT compilation, it takes me around 13.9 milliseconds, which is for without JIT compilation. Whereas with JIT compilation, I'm able to achieve 7.97 milliseconds, which is almost 50% performance improvements with JIT compilation. So JIT compilation using XLA is predominantly for faster execution speed, and the speed is your goal. Then don't look further beyond JAX. JAX, the synonym of speed is JAX. So we've covered a couple of important features of JAX. Up next, we'll be covering up more important features like automatic vectorization. So what is vectorization all about? Again, vectorization is not a new concept. It's been around for a long time as well. But what JAX does is JAX does an automatic vectorization, which takes off lot of overload for the programmer. It takes off lot of heavy lifting from the programmer. So vectorization is where you take all your for loops and any of the any of the scalar implementation which you have in your code, you convert it into a vector implementation. The reason why it is preferred is because it's an efficient way of writing programs, and it's also very very easier to debug. So let's try to understand this concept of vectorization a bit more. Here I have my hypothesis function for linear regression. I'm going to take this hypothesis function, I'm going to code it in an unvectorized form, and I'm also going to code it in a vectorized form. So if on my left hand side I have an unvectorized implementation, you take a for loop, you have to write a for loop and to write the same hypothesis function. This for loop can be converted to you can convert it to a vectorized implementation using a dot product, and that is what I've done in my right hand side. So let's see the execution time performance with regards to unvectorized and vectorized implementation. In an unvectorized implementation, I'm getting 6.4 milliseconds, whereas in vectorized implementation is giving me 18.8 microseconds. That's a huge performance gain which you can achieve by using vectorized implementation. So vectorized implementations are generally very very efficient and very very powerful. The other programming frameworks like TensorFlow, PyTorch also allows vectorization to an extent. So when you take a matrix multiplications in Torch, you also have a corresponding batch matrix multiplications, and it exposes small functionalities like this. But most of the time, you may have for a complex logic or a function or a custom function which you write, you may have to write your own vectorized implementation, which is going to be a lot of manual work, which is going to be a pain if it's going to be huge custom functions, and it requires a lot of work from the programmer. But if you do an automatic vector, JAX gives you more power using this VMAP transformation, which lets you do automatic vectorization. So I'm going to take the same activation function, which is softmax, and I'm going to take, if I have to do an automatic vectorization, I would just call the VMAP transformation and then pass this softmax, which will give me an automatic vectorization using VMAP. And this is what is automatic vectorization using VMAP. And if you want to do a parallel evaluation using PMAP, then you can use it using PMAP, where you can create JAX NumPy.np. What's the difference between parallel evaluation and automatic vectorization is Automatic vectorization is doing a parallel activity within a single device. If you want to achieve parallelization within different parts of the memory in a single device, you go for automatic vectorization. What if you have multiple devices and if you want to achieve parallelization or device parallelization, then you can go for PMAP. And so that is why here I have an activation function, and this activation function I'll be passing it jax.pmap, and then you will be able to achieve a lot of parallel evaluation using this pmap. So finally, we have come to the final important feature of JAX, which is the pseudo random number generation. So random number generation is very, very important for machine learning and deep learning frameworks, as you all know it. But JAX and NumPy differs a lot when it comes for random number generation. So if you take NumPy, so it basically uses Mersenne twister underneath to generate random numbers. So there will always be a seed which you set explicitly, but what happens beneath the setting of seed is nobody knows in NumPy world. So, but what happens beneath the setting of seed is there's a state which will be created internally by NumPy, and that state will be transformed using a transformation function every time you create a new random number. So there is no tracking of the state variable in NumPy, and that is why it's a very, very inefficient way of random number generation. Nobody knows what happens underneath, what happens to this state variable. So that is why random number generation using NumPy is very, very inefficient. But when you take up pseudo random number generation using PRNG in JAX, it's much more efficient compared to NumPy. So JAX uses three fry counter algorithm internally to generate random numbers. Let's take an example here. I'm calling random.prng key where I'm explicitly setting the state value. And then if I'm going to have 10 places where I need to generate 10 random numbers, I'll split this key into 10 and then use every key for generating a new random number. A key should be used only once in JAX. You should never reuse a key. And if you want to create new random number, then you'll have to split the key every time you want a random number, new key, and then use that new key to generate a random number. So this basically is a three fry algorithm implementation, and it's much more efficient. It allows you to do parallelization. Since you're not doing any transformations on the existing keys, or you're not depending on the existing states, and so you can do a lot of parallelization if using this method. But whereas Mersenne twister algorithm, there you cannot do much of a parallelization. It uses sequence equivalence for achieving random number generation. So it's a very, very inefficient way of generating random numbers. JAX method of generating random numbers is highly efficient. And so this here, if you see, I'm taking random.prng key where the state is set explicitly 5 or whatever state you want to set. The state variable is visible to everyone. So now I have a single state variables. If I just want two random numbers, then I can just split the key into two, and then use each key for generation of random numbers. So whenever I want more keys, then I'll be keep splitting the keys and I can generate more random numbers. So this is about pseudo random number generation using PRNG. Some more concepts which I like to highlight is JAX works really well with GPU as an accelerator. So whenever you want to calculate higher order gradients in JAX is great, because calculating higher order gradients using JAX is very, very easy. And if speed is your end goal, then JAX works really good. And when you shouldn't use JAX, again, if you're just trying to build a standard ML pipeline, then you can better off, you're just doing a POC of some concept and you just don't want to overload you with the complexities which JAX can sometimes impose. You can just stick to whatever you know. And if you have a constantly changing input shapes, then JAX may not be the right framework for you. And if performance is not your end goal, then you can just stick to your existing pipeline. You don't have to do a conversion to JAX. So depending on what your goals are, you will have to decide if you want to choose JAX or not. JAX may not be for everyone. It's very specific for your use case. And so you will have to make a decision or a call on if you want to use it or not. And finally, coming to some resources, I really found Nicholas Vadivell's JAX resources from the University of Waterloo program really, really helpful. When I first started out with JAX, that was the first video which I watched, which really inspired to give a lot of talks. So I give a lot of credit to him. And outside that, I also found the blogs at AI Summer Glow very very useful. There are particular articles which explains how to take a PyTorch transformer code block by block and convert it into JAX. And so there are a lot of useful articles with regards to JAX. I would really recommend them. Outside, there is one of the article which I have not mentioned is UBATC notebooks are available out there. You just can Google about it, and they also have a lot more examples in Flax, I think. And you have a lot of articles from DeepMind, and there's other important interesting articles which I really found useful. With this, we have come to the end of the presentation, and if you have any questions, I'll be able to answer it.
Thanks, Usha, for a wonderful, I would say, insightful talk. Because I had read a very little about JAX. Like I was hearing about, like as you told, Google has a lot of like has put up a lot of resources around those things, and these things have been coming up in the community a lot of the times. But I was not able to figure it out, or I was not able to, I would say, gather the courage to move into it. Or I would say, like, initially I thought that NumPy would do and all those things. But definitely your talk gave me a direction that, okay, why it matters and where it actually matters, and why you should use it. And in certain cases where you need to you have certain use cases of your own, maybe you don't prefer JAX at this point of time, or maybe you can prefer at a stage moving ahead. So, like, thanks for giving that direction, and thanks for making that clarification. Like, a lot of the doubts that we had, like that a few community members had sent us previously, were covered initially here also, like in your slide, like why, when we should not use it, or all those stuffs. So, like, one of the question like that a lot of the community members have sent us previously was, like, when we are trying to make a project out of it, or like let's say we try to use it as a skill, or we try to showcase it as a skill in our resume, like moving ahead when we try to apply for an internship or for a job, etc. So how we can showcase it, this JAX, like how we can talk about it to our interview, that okay, we try to use this, we try to make a project like this, or like what can be a roadmap around that.
So some of the ways you can contribute to JAX is, see, you can take the lot of research papers right now coming up in PyTorch. So you can convert that. Many of them convert it into TensorFlow, and they contribute to the Keras IO, where there's a lot of tutorials out there for TensorFlow. So you can take existing research papers, take PyTorch, and you can convert it into TensorFlow. That is one thing which you can do. And in addition to that, you can also take the existing research papers and convert it into JAX framework. And then you can reach out to JAX team, because they're always looking for open source contribution. Even if you take the JAX documentation, there are specific places where they would have clearly mentioned you can contribute. So they maintain a repository where there are already research. For example, Google has released T5. When they released T5, they released it both in JAX and TensorFlow. So for many of the research papers which Google is releasing, they release the corresponding JAX version. So they have kept a place for the community to contribute, where you can take existing research paper, convert it into JAX, and then you can contribute there as well. You can also contribute to Hugging Face transformers, where most of the transformer pre-trained models which they have it in all three frameworks. They have it in JAX, they have it in PyTorch, they have it in TensorFlow, and all. But JAX has got relatively very less contributions, so you can take up some research papers, contribute that, and that it's a very recognized, that's an open source contribution to one Hugging Face library. That will give you a lot more credibility, and you'll get hired very easily. And so official repositories of Google, and you can also take the official repositories of the Hugging Face. They have created a very specific clear pathway for you to go and contribute, and that will give you a very very credible huge credibility on your resume for sure. And outside this, you can take up a lot more projects out there. You can take even Kaggle competitions out there, and you can start. Kaggle has been conducting a year long competitions throughout this year. From January till June, they had the open source expert prize. In that prize, you have to use either JAX framework, or you should use TensorFlow framework, open source frameworks like TFLite or TensorFlow and things like that. So first 6 months they were organizing that competition, and a lot of people submitted a lot of JAX code. If you see, most of the winners were from JAX. And then they also contribute. They had another competition Kaggle hosted from July to November, where it's called Kaggle ML Research Spotlight Prize, where I won for the final November month. I won the prize. And that competition is again taking a research paper. Either you should be the original author, and you can, if you're an original author, you can just publish it in any framework, that would do. Or if you're not an original author, you can use any of the open source framework to contribute. You could have used JAX. Anybody who has written code in JAX was getting prize for sure. And so there are competitions. Keep a tab on Kaggle. They are organizing a lot more competitions right now. There's Kaggle ML reproducibility research challenge, which got released 2 days back. And so you can start contributing to you can reproduce the results of an entire research paper, and you can submit it as well. And so that is also going to be a huge thing. You'll get $25,000 in credit. So if you're going to be a winner of some of these challenges, then for sure it's going to give you a lot of credibility. So I would highly recommend checking all these forums out. And yeah, these are my suggestions.
Got it. So it's like a very comprehensive, giving a lot of direction. Like maybe if this works, go into this direction. If this works for you specifically, you can go into that direction. Thanks, Usha, for mentioning that. And we
Yeah,
have
yeah.
one of our previous speakers out here, Money. Hi, Money. So like he's asking, do you know any work that is being done to convert existing packages, frameworks to use JAX in place of NumPy, where it delivers value?
Okay, I do not know the existing frameworks as such, open source frameworks as such. I'm not aware of it. But I know one thing for sure. Recently, I've come across a lot of people tell me their entire code base. These are like some of the startups or some of the well established companies. They have their entire code base in NumPy. The reason why they don't go for frameworks like TensorFlow and PyTorch for doing machine learning, and they write their entire code in low level Python, or like low level programming, is the speed is a criteria, because you cannot achieve that kind of a performance in TensorFlow and PyTorch. So that's why they, even it is such a pain to sit and write that kind of a low level code, they still hire programmers to do that kind of a low level code. And I know a lot of companies doing this, and for them this JAX is going to be a blessing. And lot many people are not aware of JAX, which is a huge surprise for me. And for all those people who sit and write painstakingly the manual vectorization functions for all their methods, sitting and doing it's a lot of work. And some of them whom I spoke to, they were so happy to hear about JAX. They said definitely they'll give it a try. At least they'll start considering it and things like that. So I'm not aware of the open source packages as such, but a lot of companies currently they use low level Python and NumPy for their entire as their entire code base, just because of the pure performance gain which they can achieve it. And they can, again, you cannot say JAX will work for everyone. So there might be certain, because JAX has few features like immutability is not around. So there are turnaround for all those things is going to be very complex as well. So JAX exposes a lot of constraints, like for example, doing a transformation on if loops and control statements is not going to be that easy. So there are a lot of constraints, higher level, intermediate level constraints, which I've not discussed in this talk because it's a beginner level talk. Documentations has clearly mentioned those constraints. So if your code is going to use a lot of swap statements, or if it's going to use a lot of assignment statements, in place array updation, rewriting those huge chunks of code is going to be a lot of pain. So not everyone will be able to migrate to JAX. So it depends on their code base as well, what kind of statements they're trying to achieve and things like that. So for some use cases, I think it will definitely work. So it's from use case to use case. Open source libraries, I'm not aware right now. Maybe I can get back to you.
Sure, sure. Thanks, Usha. So, like, we will take up the last question of today's talk. So, it's like Yash is asking, the most interesting thing for me in JAX is the VMAP functionality, but I'm very much skeptical about the automation frameworks. I wanted to ask, what is the limit of VMAP?
Uh,
And okay,
Yeah, so the limit of VMAP is a very, very powerful transformation. So this JAX has the composition of transformation, which means, see, JIT, if you use it separately, you will achieve great transformation. And you can combine JIT is a separate transformation, VMAP is a separate transformation. You can combine JIT and VMAP and you can achieve very, very powerful performance. So JAX allows transformations on transformation. So that is powerful. But if you have multiple devices, then people generally, instead of going for VMAP, they do PMAP, because see, basically in vectorization, what you do is you're trying to achieve parallelization. So you can choose between PMAP or VMAP based on whether you're working on a single system, or you can achieve parallelization if there are multiple cores in a TPU, or if you're using multiple GPU, you can still achieve parallelization using PMAP. So people generally don't combine PMAP and VMAP. They either use VMAP or PMAP based on your use case to use case. So I've not explored much of research paper implementations and JAX and Flax at the moment. So I'm not sure I might be the right person to compare on the limitations, because I've written only one notebook so far. But from whatever I see, VMAP comes across as a powerful, transformation, and it's definitely something I look up to. But one thing which I would like to point out is, again, see, if you're going to take a project and you're going to instead of writing it from the scratch in JAX, I would highly recommend, if it's a deep learning project, then get started with Flax, because JAX has got lot of constraints which you need to keep in mind while you're converting your block of code, from TensorFlow to JAX or PyTorch to JAX. There's a lot of constraints and a lot of philosophies on which the JAX works. It's never straightforward. If you go to the documentation, you'll be able to understand what I'm trying to say. So keeping in mind all those constraints and writing a program is going to be a lot of, at least for somebody who's starting out, is going to be a lot of overload. So I would say use some high level APIs like Flax. So Flax simplifies a lot of process for you. It exposes high level APIs which you can easily call for creating neural network frameworks or doing a lot of complex operations very easily. So Flax is built on top of JAX. This is for deep learning. I would recommend go with Flax. You just understand how the philosophy of JAX works and all these things. So definitely go through JAX documentation. But if you're converting a real world projects, get started with Flax. Again, for deep learning, it's Flax. For real, you have, for reinforcement learning, you have something called RLAX, and for graph data science, you have something called JGraph. And there are so many libraries. There's a huge ecosystem of libraries which is built on top of JAX. So people don't use JAX as such, but they do understand the philosophy of how it works and things like that. So all these constraints is being simplified by these higher level APIs. So you don't have to bother or keep in mind so many of the constraints while you write the code, because these high level APIs, you can just take them, pass the parameters. If you know what does what, then you can get started with it very easily. So I would recommend exploring Flax a bit, and go through all the open source implementation. There's a repository from Nicholas Vadivelu called Awesome JAX, where he lists all the research papers from JAX and Flax, which research papers which has implementation in Flax, and everything A to Z about Flax and JAX, which you can find it on internet. The best resources has been taken by him and it is put there. So go to that. That might be a good starting point for you, and go and explore various research paper implementation, see how VMAP is being used, and that would give you a broader idea, because I have not done much of an exploration in VMAP, so I may not be able to comment on it. But I would recommend you or route you to that resource, which will give you the answer for your question.
yeah. Thanks, Usha, and thanks to all the community members for joining us at the last meetup of 2022. We hope this year was insightful as well as knowledgeable from events that you attended, and we hope that you will have more such opportunities to learn together in a community. Thanks, Usha, from the entire community for contributing to all the events, to all the talks that you have done within Kaggle days, outside Kaggle days. Like, we definitely thank you for all your contribution, and we are looking forward to learn more from you in the year to come. All the
Yeah.
best to all of
Thank you so much,
us.
Ayan.
And yes, thank you, Usha, and thanks, team.
Thank you,
Bye bye.
Ayan. Thank you, Kaggle Days Delhi. Thank you so much, audience, for coming today. Yeah. See
Yeah,
you all in 2023. Bye bye.
bye.